Well, one of my little side projects here in the shop has been to piece together some kind of backup power system that can run on AC power when there's power available, and also on battery power when AC power is gone. Very similar to what we would have in an RV, an on-grid shore power and then off-grid while you're boondocking or something type of setup. For my uses here in the shop, it would be more like a battery backup system, so that I could keep things running that needed to stay running, and also run my tools and stuff, my power tools, when the power goes out. Earlier this year, company SunGoldPower reached out to me asking if I'd be willing to test their, one of their family of inverters, and this is one of them. This is their 3,000 watt pure sine hybrid inverter. I looked at the specs and all of that and noticed that it had some pretty good capabilities. It didn't have a lot of the bells and whistles that you would see in a more expensive system like a Multi-Plus, but it had all the essential stuff that I would need for this setup, and it was actually priced a lot less than I would expect to pay for a 3,000 watt pure sine hybrid inverter, just a little over $700. So I agreed to check it out and test it. I've got this test set up here that I can walk you through, and then I'll kind of talk about some of the prime features of this inverter, and we'll do some testing and see what tools we can fire up and see how it works. So this is their 12 volt, 3,000 watt low frequency hybrid inverter. It's a pure sine inverter, so you're going to get a nice clean sine wave out of it, just like your standard household electricity, your household outlet. It's going to take that 12 volt power from your battery bank, be able to convert it to that 120 volt AC clean power. But as a hybrid inverter, it's got a couple other functions as well that you would expect. One of them is a battery charger. It's got a built-in battery charger. It can accommodate a number of different battery chemistries, and you can just kind of dial in which one you want to use. And it also has an automatic transfer switch built in here, so that you can automatically switch between grid or generator power over to off-grid battery power. And that seems to happen pretty seamlessly. We'll test that here coming up. It makes this unit a really useful inverter for most off-grid type situations where you're using maybe some solar and a generator, and periodically switch between the two. And in an RV type of situation, same thing. Maybe you're plugged in to shore power, or you're running a generator for 120 volt AC, and periodically unplug it all and just want to run off your batteries when you're going to go boondocking or be off-grid. Now, in addition to those basic hybrid inverter features, it's got a few different modes. They'll talk about it's got a power saver mode, and a number of different settings and dials and adjustments. And I was kind of surprised that it had some of these capabilities without a whole lot of fancy controls or apps. Now I want to take you through how I have it all connected, how everything's set up here for this test. And I also want to show you what's inside the box. But, I'm not an engineer, so I'm not going to attempt to explain everything inside. But if it's something you really want to see, I'll crack it open and you can have your moment and give you some nice close-ups of what's inside. One thing I will say as I put the cover back on here is that this inverter is really heavy. I mean, it is solid and very heavy. Taking it out of the box, and God, the thing must weigh close to 40 pounds. All right, let's fire it back up. Welcome. So on the battery side of the system, have it wired to these two lithium iron phosphate lithium batteries from Big Battery, and these are both 170 amp hours each, wired in parallel. So at 12 volts, that gives me what, 340 amp hours. I just have it hooked up right now using this number 2 cable and this giant Anderson connector. In reality, once I start really using this with heavy loads, I should probably upgrade this from a 2 gauge to probably a 1/0 cable. Our batteries are wired into the back of the inverter here, and they have these nice little covers on here also, so you can actually, rotate these in any way depending upon where you mount the inverter and which side you want the cables to come out of. So that's really nice. I'll just leave it off for now. There's actually 2 cooling fans, one for the DC side and then one for the AC side. And these are adjustable automatically, so they'll go between 50% and 100% depending upon the temperature of the heat sink and power load levels and all that stuff. We've got a ground here that we should connect once this is installed permanently. A remote generator start output here, so if you wanted to hook it up to a generator that was equipped with a remote start, then you could do that there. And dip switch settings here for making a few adjustments to the setup. We'll talk about that in a little bit. And we've got a remote control here for our remote control panel. So on the back of the inverter here is our AC side of the inverter. Now our input is actually here. So this is a hardwire input for our AC, 120 volt AC from the grid or from, say, a generator coming in here. So this is an input. And then the output from the inverter has a hardwired output. So this one here is actually wired to this outlet here on the top. And it also has a regular GFCI outlet. So it's nice to have both the hardwire and the regular outlet on the back of the inverter. It's got a little cover here that fits nicely over there to protect that. And it also has a couple of circuit breakers here, one for the inverter output and the charger output. Now on the front of the inverter, we've got a bunch of status lights here that show what mode the inverter's in. Right now, this light here says that it's in inverter power mode. If it switches to shore power or grid power, this little green light comes on instead. And if this one comes on, that means the charger is charging the battery. And these other ones have just various levels of state of charge for the charger, and we got a couple red ones here that are fault conditions, like over temperature and an overloading light here. Next to it here, we've got a little dial that's going to allow us to adjust the charging current, which is kind of cool. So it says it can charge up to 120 amps, but you can dial that down from 0% all the way up to 100%. It's going to depend upon your battery and a few different factors. And next to that here is this little selector to allow you to select the battery chemistry that you're using. And there's a list of them here, so you don't have to look them up in the book. It's just, 1 through, what was it, 9? Yeah, so 9 different battery charging options. Now this status display here in the corner, it cycles through a bunch of different status readings. Right now it's showing our battery voltage. It's switched to our AC mode, which is abnormal, which means that there's no AC power. Yeah, it just cycles through these different status indicators to show you what the current operating modes are and the levels. So this inverter has a few different operating modes that you can set it up for. Just depends upon how you want to use it. One of them is the grid versus battery priority mode. It's preset when you get it to be in AC priority mode. What that means is that if there is AC power coming in, it's going to run in that AC pass-through mode, and it's going to enable the battery charger and all that stuff as long as there's AC power. Now when that AC power drops off for any reason, then it's going to switch to battery power and be in inverter mode. So that's the AC priority. Now with a quick little dip switch setting in the back, you can switch it to battery mode, and they call it like solar mode. If you were connected to the grid or AC power in that battery priority mode, then it would run off of battery power in inverter mode, and then it'll only switch over to the AC mode if you reach that low battery cutoff point. There's two settings in the dip switch that you can set it to 10.5 or 10 volts. So when your battery gets down to that low voltage level, only at that point it'll switch to AC. And what you could do though is that if you had a generator auto start set up also, then it'll automatically kick on your generator, and then it'll switch to AC mode and charge mode, recharge your batteries, and then once your batteries are fully charged, then it'll switch back to battery mode. Interesting feature, could be useful if you're wanting to just have something like this run automatically and let your batteries train down to a low level. Maybe you're in a park or hooked up to AC power, but you don't want to draw off of the grid power for some reason. Maybe you've got to pay a power bill and you want to run off your solar for most of the time and then only switch to AC when the solar goes away. But like I said, the unfortunate part is that you can't control that level with this inverter. You basically have to wait for your batteries to really hit that low battery disconnect point first. So now we've got the inverter. It's running in inverter mode. It's basically generating AC power from the DC power coming from the batteries. And we're running in grid priority mode. So that means when there's AC power detected coming in, it'll automatically switch to that AC pass-through mode. So I have the AC power on a switch down here. I'll flip the switch, and what it'll do is it takes about 15 seconds to detect that signal, and there's a little delay there. I think it's because if you have it set up on a generator, so say your AC source is a generator, it gives that generator time to spin up and normalize so we get a good signal. But I'm going to flip the switch and it'll take about 15 seconds. We'll count it, and then this will switch to AC power. Here we go. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, I counted that good. Here we go. We've got AC power coming through, and you notice the battery charger light also kicked on. So it's now passing the AC power through. Everything's being powered with AC. So I got two heaters running on low and pulling in 800, 900, 1100, almost 1200 watts. Okay, now in AC mode, I've got my battery charger running, which is this little light here. And remember, I can adjust the charging current. So I put my little clamp meter on here, drawing about 30 amps from the charger right now. And I've got this little adjuster here though that I can adjust that up and down. So if I turn this to the right, it's going to basically like increase the resistance, which is going to bring down the charging current. So right now it's down to 20. I'm just slowly turning it to the right, and that's like all the way up. So that's as far down as it's going to go, is 20 amps. Now if I were to take it to the left, you should see that come up. So I'm back up to 30, 31, 32, and I can gradually increase that. You can hear the fans kicking in because it's pulling more amps. It's up to 60 right now. So the fans just went up to 100%. And then if I go all the way to the max, yeah, it's as far as I can go here. Now what I want to do is simulate a loss of AC power. So we're going to shut off the AC power and let the transfer switch over to inverter mode. Right now it's charging the batteries and it's passing through the 120 volt AC, but I'm going to switch it off and it should switch over automatically. I think 8 milliseconds is what it takes. So off we go. Heard it beep. pretty quick. Now what if we had some stuff running? So now we got AC power restored, switched back. I'm going to turn on my heater, get some heat, and we'll turn on a light. All right, so we got some stuff running, drawing about 550 watts. I'm going to go ahead and switch the AC power off now. Here we go, off. Nothing changed, everything is still running, but the inverter switched back over into inverter mode. So that switch is pretty quick. It's like 8 milliseconds, and it's not even noticeable for this equipment that's hooked up to it. So that's really good. Now the other runtime mode you select when you power the unit on, and you have two options there. You have just the standard turn the inverter on mode, and it'll go into whatever priority mode that you have it set up for. Or you can put it in this power saver mode. And that's kind of interesting because what that does is it basically puts the inverter sort of to sleep. It shoots out a little signal every 3 seconds, and then if it detects that there's an AC load out there that's I think it's 24 watts or more, then it'll say, oh hey, there's an AC load out there. I'm going to go ahead and turn the inverter on, and then power those loads up to 100%. So it just basically pulses in that power saver mode, looking for a load out there that's going to need that signal. Then when those loads shut off, then it goes back to sleep basically, and it goes into this idle mode, and it uses a lot less energy that way, but that's how it works. Okay, I'm going to go ahead and turn the inverter off, and then I'm going to switch it on into power saver mode. And right now there's no loads on the system, so it should go into this idle state. And it's not connected to AC power right now, so it's on in inverter mode. So the idea here is that I want to save my battery power and not just run the inverter constantly with no load on it. So yeah, I'm in power saver mode now. You see the little indicator light here says power saver mode basically. I don't know if you can see this, but I put a little circuit tester here, but maybe you can see this on the watt meter. It's just pulsing on and off every 3 seconds. So it's just blinking here on this little circuit tester, and just so every 3 seconds it's out there looking for an AC load. If I turn one of these heaters on, which is connected to here and a power strip down there, then it should detect that and then power on. Okay, so the heater kicked on. So now this went over into inverter mode. So it turned the inverter on, and then now it shows, yeah, I'm pulling 500 watts from the inverter. We got AC power here. We got all our lights on. We got a sine wave. So yeah, so now the inverter is running at full power and powering the AC load. Now if I were to turn this back off, then it switches back to power saver mode and shuts down the inverter. It's going to pulse again every 3 seconds to see if there's another AC load waiting to turn on. So I'm not sure how good that is for certain real sensitive equipment, but it's probably good for some things. It really is up to you how you want to use it. It's interesting that I've got this light here that it's an LED work light. I'm not going to turn it towards the camera, but it draws about 24 watts, which it says is the kind of the minimum load that it's looking for. I've noticed that sometimes it detects it right away, but it may actually take a few times because it's not drawing enough power. So it's on now. Maybe we'll see it starts to blink, so now it detected it. So it took a little bit, took a few cycles for it to kick in. And now the light's on, and we are running in inverter mode again. So if I turn this off, it's going to switch back to power saver mode. Let's switch this over to inverter mode. I'm going to turn off the AC power, and then we'll do a couple load tests running some tools in here that I would typically use in the shop, even if the power goes out. All right, back on inverter mode, just running from the batteries now. Let me fire up the table saw. Well, it turns out this watt meter has its limits, so we'll take it out of the mix, and everything's just plugged directly into the inverter now. So let's try to fire up the table saw, and then we'll try to run the shop vac at the same time. They both draw quite a bit of power, so we'll see how that goes. Better put some safety glasses on just in case. Even though the blade's down in there, might as well be safe. Here we go. Table saw. Well, that worked pretty good. Well, it looks like so far that this inverter is going to work out just fine for me here in the shop for my setup. And you know, if you're looking for something that's not incredibly expensive for your off-grid application, or you know, some sort of battery backup, this is probably something worth looking into. They have a few different inverter models as well, not just this 3,000 watt. They have a 4,000 and larger, and 24 and 48 volt setup. So I'll link to their website, SunGoldPower's website, if you want to check that out, or you know, look into that further. Oh, also, if you've got other questions that you know go into some of the features that I didn't cover in as much detail, maybe that you would have liked, I'll try to link to their manual for this one too. It's got some good diagrams in here. Say if you had a split phase AC service, you know, you got some diagrams here for how to wire those up. I'm using the 120 volt single phase on this, so pretty straightforward, but also, you know, it's got a nice diagram for just a typical off-grid backup setup, and you know, good tables for error codes and what the beeps and lights blinking and error conditions are, and what the probable causes are. So some good troubleshooting stuff. I'll link to this. But as always, you know, if you have other questions and stuff, I'll do my best to answer if you leave a comment. I'm going to be doing some more inverter related stuff as I get to work on the electrical system in the Winnebago. So stay tuned for that, but hope this was helpful for you, and I'll see you in the next one. Take it easy.